In this lesson, we will study applications using rational equations and proportions. Now, in the problems that you and I will study, they will deal with three things: distance, speed, sometimes called the rate, and time. And when these problems that we look at deal with distance, speed, or time, they're called motion problems. Translation of these problems involve the formula called the distance formula, which is distance, right here, distance is equal to rate times time. That is to say, distance is equal to the product of the speed and the time. Two alternative formulas can be considered: rate, or the speed, is equal to the quotient of the distance and the time. Time is equal to the quotient of the distance and the rate, or the distance and the speed. Which formula we will use depends on the actual problem. Example 1. The short-fin mako shark is known to have the fastest speed of all sharks. The sailfish has the fastest speed of all fish. The top speed recorded for a sailfish is approximately 25 miles per hour faster than the fastest speed of a mako shark. A sailfish can swim 14 miles in the same time that a mako shark can swim 9 miles. Find the speed of each sea animal. The first thing I would like to advise you to find or identify is, what is it that I'm looking for? What is the unknown? Identify it and give it a name. In this problem, what you're looking for is the speed. And I just noticed that I misspelled the word the here. Let me fix that for us. All right. At the very end here, it says find the speed. So we're looking for the rate or the speed of each of these sea animals. Now, it says that the sailfish is faster than the mako. It actually says the sailfish is approximately 25 miles per hour faster than the fastest speed of a mako shark. Between the sailfish and the mako, my question is, which of those two sea animals do you know least information about? Which of those two sea animals do you know least information about? The sailfish or the mako? The mako shark is what you know least information about, because they gave you something, they gave you some information about the sailfish. They said the sailfish is about 25 miles per hour faster than the mako. So they're giving you information about the sailfish. The mako shark is the sea animal that you know least information about. So that's the unknown that I will begin to name. So step number 1 is identify and name the unknown or unknowns if there's more than one. If there are two unknowns, start with the unknown for which you know least information. Because we know least information about the mako, that's where we'll start. I'm going to choose R to represent the speed of the mako shark. If this is how fast the mako shark is swimming, then the sailfish is 25 miles per hour faster than that. So I'm going to say R plus 25, that's 25 more than R, represents the speed of the sailfish. So if this is how fast the mako shark is swimming, then the sailfish is swimming 25 miles per hour faster than the mako. All right, cool. Step number 2 will be translate into a model equation. Translate these words into a model equation. Now, this might be the most difficult step, so pay close attention. Now, here we go. Starting here at this sentence. A sailfish can swim 14 miles, watch this, in the same time, I'm going to circle that, in the same time that a mako shark can swim 9 miles. So a sailfish swims 14 miles, a mako swims 9 miles, all in the same time. This phrase is going to help me set up my model equation. So allow me to move the screen up a little bit here. And here I go. So this is what I call the model equation. The time that it takes for a sailfish to swim 14 miles is equivalent to the time it takes for a mako shark to swim 9 miles. That's what the problem says. Now, because we have time is equal to time, I want to come up here and remind us what formula we're going to use. Let's use this formula here for time. Time is distance divided by speed. Distance divided by speed. So we have this time, remember time is equal to d over r, so this time must be equivalent to this time, okay? So here for the sailfish, the distance is 14 miles. Allow me to punch that in there. Over, and r represents how fast the sailfish is going. Now remember, r represents the speed for the sailfish, and we said right up here that the sailfish is traveling at a speed of r plus 25. That's the speed of the sailfish, r plus 25. So I'm going to take r plus 25 and put it down here, r plus 25 like that. And that is equal to, now here on this side, this is the distance of the mako, which is 9 miles, over, now this variable represents the speed of the mako, and we said the speed of the mako shark is just simply r. So there's our equation. Now step 3 is to solve this rational equation. Now, in order to solve this rational equation, all we have to do is multiply both sides by the LCD. Okay, the LCD is r times r plus 25, so that's what we're multiplying both sides by. Notice that this r and this r cancel, and r plus 25 and r plus 25 cancel, leaving you with 14r is equal to 9 times r plus 25. Let's go ahead and distribute this 9 here, which will give you 14r is equal to 9r plus 225. Let's move this down a little bit. So what you would get next is 5r is equal to 225. That is to say, after you divide both sides by 5, you would get 45. The last step here is to interpret your results. So what does all of this mean? All right, remember that, as I scroll up here, okay? Remember that r represents the speed of the mako shark. So this must mean that the mako shark, its fastest speed is 45 miles per hour. So I have here the mako shark swims at a speed of 45 miles per hour. Now, let's not forget that the speed of the sailfish, do you remember this expression from the beginning? R plus 25. So in this case, it'll be 45 plus 25 because that's what we found r to be, which would be 70. Do you remember that this expression represents the speed of the sailfish? So let's add that to our findings. So we have the speed of the sailfish is 70 miles per hour. Example 2. Charlie's lawn care has two three-person crews who lay sod. Crew A can lay 7 skids of sod in 4 hours, while crew B requires 6 hours to do the same job. Let's make it clear. The first crew can do it in 4 hours. The second crew needs 6 hours. So the first crew can finish sooner, or work faster, I guess, and the second crew either works a little slower or it just takes them a little longer to do so, to do the job. Question: how long would it take the two crews working together to lay 7 skids of sod? Okay, first of all, can we all agree that if it's taking crew A all by itself to 4 hours to complete the job, and it's taking crew B 6 hours all by itself to lay down the sod, if they were to join forces, let's think about this logically here. If they're working together, they should be able to complete the job in less than 6 hours. If it's taking crew B all by itself 6 hours to do it, then when they're working together, they should complete the job in less than 6 hours. And actually, in less than 4 hours. If it's taking crew A all by itself 4 hours to do the job, if they're to join forces, they should be able to complete the job in even less than 4 hours. So if we get an answer more than 4, then something's wrong. We must get something less than 4 hours. All right, step number 1, identify and name the unknowns. Now, there's actually only one unknown here. There's only one thing you're trying to find, and that is the time it takes. Time. How long would it take? You're looking for time. It takes the two crews working together. So let's give that unknown a name. How about T for time? T for time that it takes the crews to complete the job working together. So I wrote down, let T represent the time it takes for the crews to complete the job working together. That's what T represents. Now, step number 2 says to translate into a model equation. Now, to set this up and to really understand it, allow me to go off on a tangent just for a minute to explain to you how we're going to get the model equation for this kind of problem. So just go with me for a minute. I'm creating a table here to show you the meaning behind the model equation that I'm going to write down in a minute, okay? So this is just to lay down the foundation to show you how I'm coming up with the model equation. I've created this table. The first column here is all the time, okay? 1 hour, 2 hours, 3 hours, and T number of hours. On this side, it's the fraction of the job that is completed by crew A, by crew B, and when they're working together. All right, check out this first row. The problem said that crew A can do the entire job in 4 hours. That means in the first hour, a quarter of the job is completed. If they can do the whole job in 4 hours total, then in 1 hour, they've done 1/4 of the job. For crew B, it takes them 6 hours to complete the job. So that must mean in 1 hour, they have completed 1/6 of the job. Now, if they join forces and work together, then we know that in 1 hour, they will have completed a quarter plus a sixth of the job, right? The quarter that crew A does and the sixth that crew B does. Now, if we consider 2 hours, well, it'll just be double the amount of the job that they've completed in just 1 hour, right? In 2 hours, they will double their amount of work that they have done in just 1 hour. So 2 times a quarter of the job. For crew B, just by itself, it's 2 times 1/6 of the job. If they're working together, then it'll be double this amount, right? If they did this amount of the job in 1 hour, then in 2 hours, it'll be twice as much work. So it'll be twice the quarter plus twice of the sixth. And you could probably see this coming. In 3 hours, they will have tripled the amount of work they would have just done in just 1 hour, right? In 3 hours, the amount of the job that's completed by crew A alone will be 3 times 1/4. If crew B is working by itself, it'll be 3 times 1/6 of the job that's completed. And when they're working together, it'll be 3 times 1/4 plus 3 times 1/6. And that total will be the amount of the job that's completed when they're working together after 3 hours. So notice the pattern. 2 represents the time that they're working, how many hours, and this represents the rate at which they're working. 3 represents the time, and 1/4 again represents the rate. So now let's fill out this last row with T hours. In T number of hours, the amount of the job that is completed in just T hours would be T times 1/4. That's just for crew A. And when crew B is working by itself, after T number of hours, they have completed T times 1/6 of the job. And when they're working together, both crews, after T number of hours, they've completed T times 1/4 plus T times 1/6 of the job. Now keep this in mind. You can already see an expression being formed here. Now keep this in mind. We want some number T, right? Remember they said find how long it would take when both crews are working together, right? How long would it take? So you and I are looking for T. We're looking for a number T such that the fraction of the job that is completed is 1. That is to say, the job is completed. The whole job is completed. So we want an expression like this to be equal to 1. 1 representing the entire job is completed. So what I'm going to do then is take my model equation, which is T times 1/4 plus T times 1/6 is equal to 1. And this 1 right here represents the idea that the entire job is completed in T number of hours. So you and I want to find some number T that satisfies this equation. Now this equation can be rewritten as T over 4 plus T over 6 is equal to 1. Now step 3 is to solve the rational equation. We're going to do that by multiplying each term by the LCD, which is 12. Notice that 6 divides into 12 twice, 4 divides into 12 3 times, leaving you with 3T plus 2T is equal to 12. That is to say, 5T is equal to 12, or T is equal to 12/5. The last step is to interpret your results. So it takes 2 2/5 hours for both crews working together to lay 7 skids of sod. Don't forget, changing this improper fraction to a mixed number is really important in this context. Remember, 5 goes into 12 2 times, and then you'll have 2 as a remainder. That's where that 2 comes from, with the same denominator of 5. Okay, one more time. 5 goes into 12 twice. That's this whole number. And when you divide 5 into 12, you'll have 2 left over as the remainder. So that's where that 2 comes from. All right, good job, everybody. All right, we used something called the work principle in the previous problem, and I wanted to call it out. Suppose that A represents the time it takes A to do a job, and B, lowercase b, the time it takes capital B to do the same job, and T represents the time it takes them to do the job working together. Again, lowercase a represents time, lowercase b represents time. Lowercase a represents the time that it takes the first group to do a job, and lowercase b represents the time that it takes the other group to do the job. T represents the time it takes them to do the job working together. Then the following holds. T over A plus T over B is equal to 1. You may want to box this into your notes, highlight it, make sure you understand it. The time, T represents the time it takes them to complete the job working together, A represents the time it takes the first group by themselves to complete the job. B represents the time it takes the second group by themselves to complete the job. This one here represents the entire job being completed, the whole job being completed. All right, the next couple examples are going to be examples of proportions, okay? A proportion. Look at this example. A 2017 Jeep Compass Trailhawk can travel 330 miles of highway driving on 11 gallons of gas. Find the amount of gas required for 495 miles of highway driving. So what I'm going to do is I'm going to take the information that they've given me so far to set up a ratio or a rate. They said this Jeep can go 330 miles on 11 gallons of gas. So there's my ratio, 330 miles for every 11 gallons of gas. And I'm going to say that this is equal to, this is me setting up a proportion. And now watch this. Find the amount of gas required. So the gas is unknown for 495 miles of highway. I'm going to put 495 miles up here in the numerator and X down here for the unknown number of gallons of gas. Now what I want you to notice is that if once we put the miles in the numerator over here, then that means in the numerator over here must also be miles. So miles is to miles, right? Gallons is to gallons, right? So allow me to say this out loud. 330 miles is to 11 gallons of gas what 495 miles is to X number of gallons of gas. I'll say that again. 330 miles is to 11 gallons of gas what 495 miles is to X gallons of gas. Solve for X. Okay? Now, whenever you have, now this is called a proportion. A proportion is a statement that two ratios, both of these are ratio. This is a ratio and this is a ratio. And a proportion is a statement that two ratios like this are equivalent. And two ratios are equivalent if and only if their cross products are equal. So what you're going to see me do right now is cross multiply. So you're going to have 330 times x must be equal to 495 times 11, which is 5,445. So divide both sides by 330. Divide 5,445 by 330. Let's do that together. And we get that, if I can move up just a little bit, x is equal to 16 and a half. Now let's not forget what they asked us to find. I'm going to scroll back up. I don't mean to make you nauseous here. Back up, it says find the amount of gas. So this x right here represents gallons of gas. So I'm going to say 16 and a half gallons of gas. That's my final answer. Okay, 16 and a half gallons of gas. Never ever forget your units, all right, of what we're talking about. So 16 and a half gallons of gas is what it'll take for the Jeep to go 495 miles. Here's another problem where we will use a proportion to solve. A company that prepares and sells gift boxes and baskets of fruit must order quantities of fruit greater than what they need to allow for selecting fruit that meets their quality standards. The packing room supervisor keeps records and notes that, watch this, approximately 87 pears from a shipment of 1,000 do not meet the company standards. Over the holidays, a shipment of 3,200 pears is ordered. How many pears can the company expect will not meet the quality required? All right, let's set up our first ratio. I'm going to take the initial information that they gave me, which is 87 pairs, 87 pairs out of 1,000. That's a ratio right there. 87 pairs out of 1,000 altogether must be equal to some number of pairs that will not meet the quality standard out of the 3,200 pairs. Does that make sense, everybody? 87 pairs is to 1,000. Now, this is the number of pairs that do not meet the quality standard. So 87 is to 1,000. What P number of pairs is to 3,200. It's so important that the numerators match in that both of these values represent how many pairs are not meeting the standard. And these two values must match in that these are the total number of pairs that are being ordered. Okay? All right, let's cross multiply because a proportion is true if and only if their cross products are equal. So I'm going to multiply both sides, or I'm going to cross multiply. So it'll be 1,000p is equal to 87 times 3,200, which is 278,400. What I'll do is divide both sides by 1,000. Let me move this screen up a little bit here, about there. I'm dividing by 1,000. And I get P is equal to 278.4. Now, this is the number of pairs that will not meet the standard, okay? So let us approximate here. Let's either keep the number 278 or round up to 279. Because this number here is less than 5, I'll round it to 278. So something like this would be great. In an order of 3,200 pairs, about 278 pairs will not meet the quality standards. Now the last two examples are having to do with similar triangles. Now, as a reminder, in similar triangles, corresponding angles have the same measure. And right here, this is important. The lengths of corresponding sides are proportional. Triangles ABC and XYZ are similar triangles. So both of these are similar triangles. So right there, it tells you, because they're similar triangles, that the lengths of corresponding sides are proportional. Okay? Solve for Z. Find this side length right here. If side A is 8, right? This side C is 5 units. And side X here is 10 units. So let me show you what it means when we say the lengths of corresponding sides are proportional. What I can do is set up a proportion like this that says Z is to 5 what 10 is to 8, because these two triangles are similar. Now, similar does not mean congruent. Congruent would mean the same size and the same shape. Similar triangles don't necessarily have the same size, but they have the same shape. Okay, this triangle does look a little bigger than this one, so similarity just means that the corresponding angles have the same measure and the lengths of corresponding sides are proportional. So I can set this up. Z is to 5 what 10 is to 8. This side length is to this side length what this side length is to that one. That's us setting up a proportion. What we can do now is cross multiply. Make sure you do not cross cancel. You're not allowed to cross cancel at all. Not when you have a proportion. So then this is 8Z is equal to 50. Divide both sides by 8 to get that Z is 50 over, oops, sorry about that, 50 over 8, right? Which is, when we simplify, 25/4. Good job, everybody. This is the value of z. I said earlier that you're not allowed to cross cancel. Let me take you back up here, right up here. And before I cross multiplied, I had an equal sign. It might be tempted for some people to cross cancel between the 5 and 10. You could only do that if this were multiplication, but it's not. It's an equal sign, so you cannot cross cancel here at all. The only thing you could do is cross multiply. That's very important. All right, cool. I hope you learned a lot in this lesson. This will be the end of this lesson. I will catch you in the next one. See you later.